This talk is called Many Formats, One Data Lake. If we were to have a different title, it probably would be Avro to the Rescue. And if you don't know what Avro can do for you, this talk will help show you some of the things. And let's go ahead and dive in. So during this talk, I'm going to give a brief talk about kind of what inspired the talk first. That'll involve data lakes and some non-traditional requirements for that data lake, and that's actually something that happens as a result of who the client of the data lake was. We'll discuss Avro and sandwiches, and I'll give a reference to a previous talk actually that inspired some of the work here that I think is still relevant today. That you can take a look at sometime later. We'll discuss kind of writing multiple outputs to a data lake and what the pros and cons of doing that might be. Might sound like a crazy idea, but it was something that we needed to do, and I'll explain why. I'll offer some code level tips for some of you that are interested in doing some of the things that are presented here, along with a library that may help. And we'll wrap up with Q&A and a discussion if you're curious. So why don't we go ahead and dive into that. First off, a little bit about me. My name is Peter. I'm a consultant working for my own company, and I've been using Beam for about 3 years. I have a Java and TypeScript and Python-ish background of sorts, and I do stutter. So if you notice me repeating words, it's not the stream. Don't worry, it's actually just me, and that's totally fine. I actually like the Beam Java on the development side. I think it does a really good job of managing data types and giving me compile time assurances of when I do things wrong. I think it also does a pretty good job of actually telling me what happened at runtime, which in distributed processing systems, as we all know, can be a bit of a challenge. And while the stack traces are long, at least the data is there when you know where to look. So I also like old logos, which might be a weird thing to bring up here, but we'll discuss some of the old logos that are related to this talk in the middle, just to give us a little bit of a break of things. And finally, I also absolutely love unit testing. So if you ask a question about unit testing, you better be committed to it, because I will get very excited, and we'll talk way more about it than you probably want to hear. But that's just the way that I'm built, I think. So I'm not a fan of running containers inside of containers. To me, that feels like one more layer of abstraction than I've ever wanted, and that's actually meaning something coming from a Java developer, that there's one too many layers of abstraction. No Java developer jokes in the crowd? Okay, that's fine. We'll move on. Something else that might be sort of confrontational for the group is I'm not a fan of optional fields. I feel like that's like one more if-else statement that I'm going to have to put in my code somewhere, that I'm then going to have to unit test somewhere. And that's something that I tend to kind of try to shy away from at times, although they show up in a data processing all the time. I also don't love debugging Claude code. I like using Claude code. It's a great tool until it isn't. If you haven't used it, you'll understand that sentence almost as soon as you start using it. That's something that can be very helpful, but can also kind of slow you down at times in unusual ways. So I do have a geek claim to fame that's both true and a little silly. That's kind of fun to talk through here. So I once worked for a group that built a management software for large-scale computing systems, and we once got an email from Dr. Hawking saying that the management software we built was, quote, okay, end quote. And I'm actually kind of proud of getting that. And so your life lesson for the day, if you want one, is sometimes it's good to be proud of just being okay, because if Dr. Hawking thought that was good, then I'll take it. That's my geek claim to fame. So the ideas from this talk came from building an application, and the application can best be described as a community impact measurement tool, and that's kind of a mouthful by itself. But with it, you can answer questions like, if a company deployed capital to a given location, deploying capital here is giving loans or spending money, right? So if a company deployed that capital to a given location, what's the overall financial impact on that community? And more interestingly, you could say, if a company were to deploy capital in a different way, what would the impact be in that community, and how would that be a different impact than what they're currently doing? The idea behind the tool is that we should give large-scale corporations, especially, a pretty good view into sort of how they spend their money, and show them how it matters. As in, if they were to say give loans to people outside of their normal types of customers that they give loans to, how would that improve or change the impact on the community where they're giving the loans? So so it's a fun tool, and it's actually something that's a really easy mission to get behind for sure because of the community impact side of it. The tool worked by gathering data from a bunch of broad data sets, things like the U.S. Census, proprietary data, geolocation, and so on. And then from the user's perspective, it worked. We do a lot of data magic in the middle of there, and like that would be the fancy piece that they wouldn't quite follow. But given a location and a description of how a company was spending money in that location, we could generate a lot of interesting charts and graphs and show them a lot of cool things about how that company was impacting the community. And then the great thing was that we also could do that same analysis for any other location throughout the country. And when I say location, I don't mean a county or a city. Like this could drill down to a census block level, which is about 3 city blocks if you're looking at New York City, for instance, and zoom out to the state or the nation level. So it lets you do the same analysis for the same deployed capital at many different layers. But the key point to really get to here is just that this is sucking in data from the left-hand side. It's doing data processing, and it's spitting out charts to the right-hand side, right? So conceptually, this is a classic data processing application. And a typical data flow would look something like this in the end, right? We call the U.S. Census API. We would actually be doing that from Apache Beam pipelines running in data flow. We do some processing on them. We produce the outputs of the data and put them into GCS. We would then build an external table within Google BigQuery to read the data from there, and then we'd have a web application that would do SQL queries against the external tables and use those to generate those beautiful charts that the users wanted to see. So the 3 steps in the middle here can definitely be described as a classic data lake, right? And I like that there's nothing particularly unique about them at this point. And so it's pretty obvious, I think, that like a project like this could benefit greatly from a data lake architecture. And because we plan on producing a whole lot of really interesting data from these things and actually spitting them out in a pretty large scales, and we wanted to democratize access to that data as much as we possibly could. So when we were first laying the groundwork for this, we kind of assumed that we'd have a classic data lake like this in mind. Data would flow in from the left-hand side. We'd write some Apache Beam code to actually translate whatever it was into a single data format. We'd land them in the data lake as a text files. We would then have a data lakehouse of some sort, which a BigQuery serves the purpose here pretty well, and our users, which would include basically the web application and anyone else who wanted access to the data, would sit on the right-hand side of the data lake, and they would write SQL to do everything from exploring the data to running ad hoc queries to drawing their charts and so on. This was the naive version that we assumed that we would build when we first started this project. However, as we worked with the client a little bit further about what they wanted, they actually really liked the idea of the data lake, and they wanted to actually make a lot of use of that, and they started to come up with other interesting requirements and things that they wanted to see there, that led to some quirks in the details about what we had to build for them. The first quirk was that the pipelines we ended up writing were doing a lot more than just transforming data sets. So we weren't simply I'm going to read in things and to dump Parquet to the data lake. This was based on the needs of the web application in particular, which kind of wanted to pre-render a lot of the common data calculations that we expected them to do, so that the data access speeds from the web application would be as performant as possible. For instance, we had a number of analyses that would run at a neighborhood level, and we wanted to give the application the ability to see the results of of the analyses in a lot of different ways. For instance, show me the top 10 neighborhoods for metric A. Don't just show me the metric A of this neighborhood, but show me the top 10 neighborhoods throughout the entire country, of which, by the way, the data set that we're using, there are about 85,000 neighborhoods. If you're looking for a quote for the number of neighborhoods in the United States, about 85K is what the data says. Or show me the worst neighborhood for metric B in the entire country, or show me some aggregated value of metric C for the bottom 10 neighborhoods in Massachusetts in the year of 2022. So we wanted to give we wanted to give the web application the ability to ask questions like that of the data set and not have to do a lot of complex SQL to do that. The people who were writing the web application were very good software developers, but not very good data folks. So we wanted to actually do this work and make sure that we could make a performant web application for them. So this led to much more complex pipelines than just take the data and make it Parquet and spit it out. It was the first quirk that we had. The second quirk kind of came from the first, in that we didn't end up just needing to do ETL sorts of jobs here. We wanted to do a lot of the transformation of the data at the same time. So suddenly we had these kind of foundational data sets within the data lake that the data folks at the client saw. If we actually blended those with additional data sets that we could bring in, we could produce doubly valuable data for them to read, and that they got very excited about that. So it created a situation where a lot of our pipelines wanted to read the entirety of a data set out of the data lake as a part of ingesting a different set of data. So we needed to pull stuff out of things and do the same sort of a pre-calculations of things. And like a lot like the idea of kind of pre-rendering the results, this was actually important to guarantee the speed of the access for the web application to get to these things too. And typically these kind of derivative pipelines wanted to read the entire data set, not just specific columns. So while we could read the Parquet files from this, that's not necessarily the most efficient format to read the entire data set from at that point. So one third quirk is a pretty weird one when I'm talking to a group of software developers, because this seems crazy. I have to actually mention that the client of this was a consulting company, not a software development company. So when they saw the sort of data that we were producing into the data lake, some of them got very, very excited, and they wanted to have the option to pull CSV data directly out of the data lake for certain types of users. I think the easiest way to encapsulate this requirement is this. You can get the data out of Excel, but you can't get Excel out of the data processing process. That's the sad truth of the world, especially for this project at least. And while it was possible for the users to use a data lakehouse pattern to actually access these things, to say, please generate a CSV that looks like this, they found that to be burdensome, and they just wanted local files. They wanted to be able to use their pre-existing calculations and business processes that they had used in the past, and they wanted to be able to draw their own charts in spreadsheets, which made the web app people kind of sad, but that's how the beauty of data works sometimes. So we want to make the client happy and want to provide direct access for certain people, for certain data sets that were of a suitable size to do this. And then one final quirk is that we wanted to make sure that we were prepared for other data formats we might ask to be supported in the future. So despite many folks' best efforts, XML refuses to die. I actually saw a talk here yesterday where in the medical field, there's a company that is trying to actually translate their format into XML because it's modern for them. So that will probably live longer than we will. And there are several other data formats that are still broadly used too. And we also knew at some point someone was going to ask for Iceberg tables, because like we saw this morning, that's the direction that we are all going at some point. People love the idea of snapshots of data. And that while we didn't want to build these things right away, we did want to make sure that the path to supporting them was as clean as possible in the future, is the general idea here. So to summarize, our pipelines ended up needing to be able to ingest Parquet, CSV, and Avro and bespoke API calls too. And in the future, we might want to ingest other text data types other text data types like protobuf and ORC and so on. At the same time, we also need to produce Parquet for the data lakehouse tools, CSV for those weird raw data users that wanted it, and we decided that we wanted to be able to produce Avro for the reentrant pipelines, the pipelines that were deriving data from existing data, sort of thing. And finally, we wanted to have a clear path towards future formats. It was the general idea of what we were trying to build. So in the end, this data lake looked a little bit more like this, and this is a zoomed out version, but the best that I could do, I think, with the slides. This has multiple complex inputs coming into the data lake. It has multiple file formats in the data lake itself, consistently representing the same data but in different types of files. We have the ability to reread certain data sets out when producing others, and we have the ability to expose either raw CSV for certain users or Parquet for the data lakehouse tools. It's very much worth admitting that this is not my father's data lake. This is a pretty non-standard one, but it's the data lake that the client needed. So we needed to go figure out how to build it. So around the time we were laying the foundations for this, I actually came to Beam Summit 2023. And I happened to actually see a great talk, the full name of which is A Beginner's Guide to Avro and Beam Schema Without Smashing Your Keyboard, which was Devins, who's sitting in the back, by the way, who gave a wonderful talk. So it's worth your time to actually go watch it at some point. It does a really good job of actually diving into Avro and Beam Schema and some of the unique use cases. And this really influenced a lot of our thinking about how we're going to build the data pipelines for the data lake that we needed to build. Key to the talk was the idea of standardizing the inputs and outputs of all of their pipelines, and they settled on what they referred to as an Avro sandwich, where Avro was the bread, and POJOs and custom formats were the filling for all of their pipelines, and they show a lot of benefits that you can get from doing something like that. And we were pretty intrigued about the idea, and it led us to dive a lot deeper into how Avro could be used to standardize the data for ourselves, even if we needed to read and write other outputs on the sides of the sandwich in the end. But before we go too further, we need to talk a little bit about what Avro is and Avro is not. Avro is a text-based data format, but it's known, at least more broadly, for its schema definition language. So you may have seen data sets that end in dot Avro, but it's probably more likely that you've seen or will see things like this instead. This is actually an Avro schema definition, and it's just a JSON document that has a couple of fields on it. They support primitive types. They support complex types like records and enumerations and maps and so on. Avro came out of Hadoop a long time ago, and one of the ways that it differs from some of its competitors, like protobuf and so on, is that its format hasn't changed in the 12 plus years since they all kind of exploded on to the scene. It has had records and enumerations since version 1, and the current version of Avro is 1.12, I think. But the feature set hasn't changed very much since it was first launched, and you couldn't say that for serialization formats that it's been really competing with. And this is actually a pretty good benefit of the platform, is that it hasn't changed, and so it has a lot of tooling support that we'll talk about a little bit further. But this is the classic example of a schema that's describing a user type, and the user will have a name that's of type string, and it will have a favorite number, or it may have a favorite number, or that might be null, and it may have a favorite color too that might be a string. There are some quirks with whether this is perfectly defined or not, but let's not worry too much about that. But the nice thing about having an Avro schema for the data that you're working with is that it then opens up a lot of different things that you can do with tools that support it. But if you're working in the Java language, probably the very next thing that you're going to do is take this and use the Avro tools compiler to generate a well-formed Java class out of the schema definition. And don't let this scare you. I've never written this line of code in my entire development career. But technically speaking, if you want to run the Avro tools compiler to compile a schema file that's defined as that into a destination, you can run it this way. Actually, I think I did run it once just to confirm that it worked, but the 99% use case is let your build process do it, and this will generate a class that actually lines up with the schema that you've defined, that you can then use to actually represent the schema within your Java-based program. And the great thing, like the reason that we're talking about them here at a Beam conference, is that these are great things for backing P collections in the end. You can actually use these and get a lot of benefits. If you can integrate Beam and Avro well, you get a lot of compile time and runtime benefits from having your P collections be backed by Avro classes. And we'll talk a lot about those a little bit later in this talk. Here's an example of what a generated class might look like in the end. This is actually the user class. I generated it and then stripped out a bunch of details so so that we can focus on a few things. It's not pretty, but it does show off a couple of useful features. First off, the Avro schema itself is embedded into the class as a public static final field, so you can always have it. The generated code also includes a binary encoding and decoding details, which can be leveraged by Beam coders if you do it the right way. It also includes constructors, one of which is completely empty and one of which is completely full, which is useful. And this is the sort of code that you get from the Avro compiler when you run it out. When I first started using this, I was really nervous about using generated code. I am not a fan. Generally speaking, like I thought it would be brittle and a chore to work with, but I admit that I was wrong about that. This actually has a lot more features to these generated classes that really helped a lot, and they ended up not being a chore to work with whatsoever. Let the build tools build them, and then use them, and suddenly you get a lot of benefits. So a reasonable question that you might ask is: suppose you go through the trouble of modeling your data with these Avro schema, what benefits do you get out of this? Because it's not free, it is work that you have to do. And the answer is you get a lot. Like I mentioned up front, this is a pretty old piece of technology, so it's supported by a lot of different tools, for one. This is actually far from a complete list, I think, but it does give you a taste. Like Amazon Glue, you can use it as the canonical way to actually define your AWS data catalog. Athena and Redshift can serialize and deserialize data described by Avro natively by themselves without you doing much. Google PubSub treats it as the canonical way to define the schema of the message. So many people have probably seen these before and gone, "What's Avro? I don't care. I'm just gonna use it to describe my PubSub message and to move on." The great thing about it is that PubSub then strips out the schema for you whenever it transmits the message, but gives you 100% guarantee that you can only publish message with that format, and you can only consume messages from that format. So you get great runtime compatibility, and Kafka has a very similar functionality for it if you're using that as your PubSub mechanism. And BigQuery can read and write it natively as well. Dataplex is a data catalog offering from a GCS2, which you can automatically infer the schema of Avro files to use that to define your data catalog as well. So this is just a list from 2 cloud providers. It's an old technology, and that means that there are lots of it, and it hasn't changed much. Like I said, the stability of it has definitely helped. So once tools build support for it, it doesn't really go away, which makes it a very nice thing to build around, in my view, I think. The second benefit is very much the sandwich idea, and the way that I can actually describe this in my own words, I think, is just that it really helps define the borders of a pipeline in a clear language agnostic way. And if you remember, we were building pipelines that were feeding other pipelines that were feeding other pipelines, and And a really simple way for us to define the interface between those was just show me your schema, and I'll make sure that my pipeline that's feeding yours actually does meet this language agnostic schema for whatever use case that you have for it. And this is really sort of the biggest benefit that we found from the developer perspective, was that these things became documentation worthy. So whenever someone would ask me a question about what my pipeline was producing, I would always respond with a link to the schema and say it's producing this. Don't ask the questions. Go look at the canonical source. And as a developer, that also meant that we had kind of compile time guarantees that we were producing data types that were correct, or that we were consuming what the pipeline would expect it to consume. And this let us focus a lot more on the complexities of the pipeline itself and the transformations we were doing, instead of worrying about what's coming in or what's going out. Compile time guarantees can be really helpful at simplifying or at lowering the level of complexity that you have to think about as a developer. And one more benefit is basically just that if you have a P collection that is backed by an Avro described data transfer object like this, you can very easily get a Beam schema from it. A Beam schema is different than an Avro schema. And in many cases, the Beam schema will come for free. If you're not familiar with Beam schema, this is at the start of the page from the Beam Programmer's Guide. Formally defines the elements of a P collection as an ordered list of named fields. And like Avro, it supports a bunch of primitive types as well as a nested fields and maps and so on. In other words, it's a lot like an Avro schema, except it exists at runtime, and the Beam SDK understands how to work with it natively. And that gives you a lot of interesting things that you can do whenever your P collection has a backing schema for it. So here's actually a high-level summary of the two. The Avro schema can be used both inside and outside of a Beam pipeline. If you actually are reading with the Avro IO class, you get a Beam schema for free. However, if you're producing Avro instances into a collection where you're not reading it, they may not have a Beam schema, but we can talk about how you can solve that problem in just a minute, because it can be confusing if some P collections that you have are schemified and some are not. That actually makes for a challenging developer experience for sure. Beam schemas are useful within the pipeline itself, but really nowhere else. But when they do exist, you get a whole bunch of useful transformations. Convert is probably the most well known. This is something that if you have two classes that share the same Beam schema, you can very easily use one in place of the other, or move between them whenever you want. And the Beam SDK will do the expected thing for you, basically. And this also means when you have them, you can join and select and group and filter typically by field names instead of by the entire object that you're working with, and that includes a lot of shortcuts for when you're writing do functions as well, with a field access and element annotations. The long story short here is basically if you have a Beam schema, your Beam code is a lot easier to write. That's the simplest way to think about this, I think. So in the end, we ended up leveraging the Avro sandwich idea pretty heavily, except we accepted any inputs we could from the left-hand side, and we immediately converted everything into Avro-generated classes. This let us benefit from the schema and the standard generated classes, but also from the Beam schema support. Within the pipeline, we typically use a mix of Avro schema objects and POJOs. In hindsight, I feel like it probably would have been a better developer experience if we just stuck to the Avro schema objects as the DTOs, but the project that we were working on, the POJO approach worked well enough. And when data was ready for publishing to the data lake, we convert everything back into an Avro generated class. And the reason for that is that then that made writing the layer that did this translation into 3 different types pretty easy, because you knew that it was going to have a schema object to work with that perfectly described the data that you wanted in the first place. So this design really allowed us to meet the unique needs of the data lake, and that meant that we could actually get our jobs done and make the client happy, which was the whole goal of the entire thing. Some of the benefits and the drawbacks here. First off, Avro's definition of the inputs and the pipelines made it very clear. And so I was talking about this at a lunch too. Avro is boring, and boring technology is really good to build around sometimes. Sometimes it really helps you in that if you're using something that is not bleeding edge, you're actually going to get a huge amount of value from it. And this let us, like I mentioned, focus on the data transformations and the non-trivial calculations we were doing within the pipelines without worrying too much about what was coming in and what was being spit out of the pipeline. Second, the built-in schema support made it simple for us to not worry about where the data came from and what the runtime shape was. The standard base class that shows up for the data transfer object there really helps you do some of the basic things very well. And finally, we got the different formats we needed to meet our unique data lake needs. On the other hand, making all of your input and output types Avro schemas is not free. So you do actually have to do the work there. So if you have some complex data types that you're reading or writing, this is non-trivial work. I would make the point though that if you have these non-trivial types, the documentation lift that you get by documenting them as schema is worth the effort by itself, even if you never actually use the generated classes. Second off, if your pipeline is IO bound, then rewriting the data multiple times certainly won't help. This usually happens in parallel though, so that's kind of less of a concern. The biggest concern is sort of the cost and the data swamp idea, as in if you already don't have great control over what's being written to your data lake, then writing it 3 times will mean you'll have 3 times less control. So that's something that the data catalogs can help with, but that's a problem whether you're tripling your writes or not, I would say. So a couple of tips if you want to do something similar. The first tip is one that you don't really see very clearly until you've actually played with it long enough. But when you're declaring your schema, there's a feature that lets you do this, that lets you actually specify these are Java annotations that I want to be attached directly to the generated class that I'm going to get. And we found that having 2 of these on all of the schemas actually just made a lot of sense. The first one is very much the default schema. So if you do this and you specify the schema record, the Avro record schema as the default beam schema of the object that's going to be generated, then you will always have schemaed objects generated regardless of whether you read them via one of the IO classes or you generated them on the fly yourself. So it's a simple thing to do to make sure that you always have a beam schema. The second one is to tell the encoder to use the Avro coder class by default, which basically means that then the generated the generated coders actually will then be used by the Beam SDK when it's running, and they're very efficient, and they're better than the default serializable coder in terms of both time and space. And there's really no reason not to use them at this point. So we actually found just by sticking these 2 on all of the schema definitions had practically no drawbacks and a lot of benefits. A second tip is to learn to love the generated classes. That took me some time, but I got there. They are Java beans, and so that actually helps you work with tools and techniques that expect that pattern. They implement a really nice builder pattern for actually letting you actually make new versions that are copies of the old ones with modifications that makes testing pretty easy. They have the schema built into them, which can be helpful for really complex use cases. We actually had one use case where we wanted to rewrite the schema out as a JSON I'm document sometime later, basically, for instance, that was useful for. Um, you also can set specific options on the Avro compiler when you run it so that it doesn't generate setter methods. And by that, you automatically get immutable classes, which who doesn't love immutable classes? You will love them as soon as you hit a bug that took you days to find, I would say. And so while they are pretty ugly classes, they're kind of readable once you get used to them. Like I found myself in more than one case setting a breakpoint inside of a getter of a generated class to find a weird serialization problem that Amma was having. And so when I was actually setting breakpoints inside of generated code, I realized that I had learned to love these things in the end. So it worked better than I thought, is the short version of that. And then this is a simple tip, and just don't think too hard about it, but alphabetize your fields. This is the same example, except that favorite color comes first, and favorite number comes second, and name comes third. And the reason for this is that having a predictable field ordering scheme matters when you're translating between types, because some of the file types actually the field order really matters, and if you get it wrong, it's a really confusing bug to hit, where you think something should be a string and it's passing a float, and you're like, how in the world did I get here? Like who would confuse a string with a float? And the answer is ordering is usually what what happens there. So it seems silly, but we found forcing ourselves to do this made us think about the field ordering consistently, especially in code reviews and those sort of things. So hey, by the way, you may not have noticed this is favorite C versus favorite N. Please flip those sort of thing or something like that. So that just made us pay attention to it a bit more. And then the final tip is very much, if you are going to do something like this, don't do it yourself. When we were building this community impact measurement tool, we generated we created a general purpose library to handle the translations between the two. And I've since recreated the library. I couldn't use the code from the client, but it was pretty straightforward to actually build another library that does something similar. And so this thing supports reading of Avro and CSV and Parquet and new line delimited JSON files, which was a format that I hadn't ever thought existed until I worked with Zendesk. If you need to do large scale Zendesk tickets, sorts of things, that's their format of choice, which was weird, but okay. And this library basically wraps around file IO and Parquet IO and friends, but provides a pretty uniform class for reading and writing the data. So if any of the techniques that I've talked about actually are things actually that you'd like to play around with, this is probably worth exploring. You can use it as inspiration for a library yourself. You can help me improve this one. It is up to you. And one thing that I sort of stumbled over that's fascinating is I did say that it does read CSV, which seems like a pretty boring thing again, until you try to do it with the CSV IO, and you discover that reading CSV files is not yet implemented. So if you want a library that can read CSV, here's one. And you might think that this is a sort of silly, because all you have to do is use a text IO to get each line and then split by commas and you're done, right? And the answer is CSV is so far from a standard that doesn't work. This wraps around a library called OpenCSV that's been around for a long time that does a great job of streaming the data through and actually works quite well. So what does it look like in code? It looks something like this. So if you wanted to read from mybucket/data/movie star.csv, you would create a new reader from Transbeamer. You would give it the format that you want it to expect it to use. You give it the location and the Avro generated class, and then you can filter the files if you want to, and a few other builder methods like that as well. And that would actually read you a P collection of movies, where movie is an Avro generated class that actually represents the same structure as the CSV. If you wanted to read Avro or Parquet or new line delimited JSON, you change this line, and it figures it out basically. Writing looks pretty similar. You create a new writer, you tell it the format, you tell it the location, you tell it the Avro the Avro generated class that you are writing from, and you can give it a file prefix as well, and this would write to mybucket /results /modmovies star.parquet or star.avro, and the location here can be whatever is supported by file I/O in the end. So you can write to a GCS, you can write to S3, you can write to local file systems. It's the same idea. So to summarize, we had some unusual requirements for the data lake that the client needed. We found that standardizing the inputs and the outputs of the data lake was easiest if we used Avro schema to define the borders of the pipeline itself. We implemented a library to handle the format conversions coming into and out of the pipeline, and that allowed us to build pipelines in a kind of a consistent manner that let us accept whatever input formats we required, and then output multiple formats to the data lake at the same time.